Hello, you're welcome to my channel. Today we are learning about coordinate geometry. What's coordinate geometry all about? Well, geometry of coordinates? Not really. So, coordinate geometry happens to be that common ground between geometry, which is the study of lines, shapes, and angles, and algebra. It's like a mix of studying both geometry and algebra together using graphs and lines and curves. Stay with me. Now, when we talk about coordinate geometry, I want us to first and foremost focus on that first word, coordinate. Now, what do we mean by coordinates? In mathematics, we write our coordinates in pairs, especially when we're talking about the plane shape. What do I mean by a plane shape? Something on the flat surface. So if we're talking about coordinates as regards plane shapes, we'll be looking at just x and y. X being our horizontal axis and y being our vertical axis. So whenever you need to write down a pair of coordinates, please remember you need to write the x coordinate first before the y coordinate. This is critically important. Coordinate pairs are written in terms of x, comma, y. Never switch it. You don't write yx. This means something else. This is a big no. This is what you need to write always. All right. Now, when we talk about coordinate geometry, there are a couple of subtopics that might come up. First and foremost, we begin to consider the straight line and its gradient. How do we find the gradient of a straight line? Gradient basically means the slope of the line. Now, how do we find the slope of a line? We talk about its rise divided by its run. Let me take that again. The gradient is just the rise of a line divided by its run. It's the relationship between the change along the y-axis and the change along the x-axis. So before you can find the gradient of any line at all, you need to have two pairs of coordinates. Now let's take an example with this line we have here. The coordinate at this junction will be the x value is 0, while the y value is 2. That's the coordinate here. I'm going to pick this as my second pair of coordinates. The x value here is 6 and the y value is 8. So if I'm told to find the gradient of this line, I have two pairs of coordinates. Another very important thing I need to do is to label my coordinates. Now, these are the first pair of coordinates here, so I'm going to label them x1, y1. Whereas this is the second pair, I'm going to label them x2, y2. You will realize in a couple of seconds why this is important. If you don't label them appropriately, you might begin to mix up the numbers. So let's find the gradient of our line. This particular line now, we know it is y2 minus y1. Our y2 is 8 minus y1 is 2 divided by our x2 is 6 minus our x1, which is 0. So this is going to be 8 minus 2 gives us 6. 6 minus 0 also gives us 6. It means that this line has a gradient of 1. So m for this particular line is 1. Now, you remember we said this is a straight line. There is a general equation of straight lines. It is written as y equals mx plus c. Y equals mx plus c. Now, your m here represents your gradient, while your c represents your y-intercept. What did I say? M represents your gradient and your c represents your y-intercept. What is the y-intercept? The y-intercept is where the line cuts or crosses the y-axis. Remember, this is our y-axis here, and this line is cutting the y-axis at this point. It's cutting the y-axis at 2. Therefore, we can write the equation of this straight line as y equals, what's our m? 1, x plus c. What is our c here? our y is 2 there. So the equation of this line turns out to be y equals x plus 2. So whenever you're told to find the equation of a line and you're given 2 points, this is what you need to do. First and foremost, you find your gradient, which is your m, changing y over changing x, and then you identify where your line cuts the y-axis, and you put that together. Aside from talking about the gradient of a line or the general equation of a straight line, oftentimes we are being asked for the midpoint of a line segment. Please note, when we talk about a line segment is just a portion of a line. When we talk of a straight line generally, a straight line represents something hypothetically endless. It doesn't have a start or end point. Imagine your number line. That's a straight line. It is endless. But when you talk about a line segment, it has an hypothetical start point and an end point. To find the midpoint of a line segment, it's like you're finding the average of the x coordinates and the average of the y coordinates. Now let's go back to our x and y coordinates. We have our 0, 2, and we have 6, 8. This is x1 and this is y1. This is x2 and this is y2. So to find the midpoint of this our line segment, it's going to be x1, that is 0, plus x2, that is 6, divided by 2. And for the y, it's going to be y1, that is 2, plus y2, that is 8, also divided by 2. 0 plus 6 is 6 divided by 2. That's going to give us 3. And 2 plus 8 is 10 divided by 2. That is 5. So the midpoint of this particular line segment is going to be 3, 5, right here. All right. Another thing we could be asked to find is the length of the line segment. And here's the formula here. So to find the length of this particular line segment, we just apply our formula. You can now see why it is critically important for you to label your pairs of coordinates correctly. All right, so for this line segment, x2 minus x1, our x2 being 6 minus x1, 0, all square, plus y2, 8 minus y1, 2 square. And this is going to give us the square root of 6 square plus 6 square. When you evaluate that, it turns out to be the square root of 72, because 6 square is 36, and another 6 square is 36. 36 plus 36 is 72. If we want to simplify this, it becomes 6 root 2. All right. And when you evaluate this, it gives 8.485 and so on. To 3 significant figures, this will be what? 8.49. Now, some other major concepts we'll be looking at under coordinate geometry is the idea of parallel lines. Parallel lines are lines that are going in the same direction, all right, and they have a fixed distance between them. Algebraically, parallel lines have the same gradient, which means the gradient of the first line is exactly the same thing as the gradient of the second line. So since m represents our gradient, we know that m1 equals m2. Now, the other concept we'll be looking at is perpendicular lines. What are perpendicular lines? Perpendicular lines are lines that intersect at 90 degrees. Both lines intersect each other at 90 degrees. When you have a pair of perpendicular lines, the relationship between their gradient is that the product of both gradients will give you -1. Again, looking at it in another way, the gradient of one is the negative reciprocal of the gradient of the other line. I know this is a whole lot to take in, and you're wondering, what am I going to do with all of these different approaches? Not to worry. In the next video, we are going to be looking at exam style questions based on coordinate geometry. Stay with me. Thank you for watching. See you in that video. Please subscribe, like, and share. Also turn on the notification bell.